Now we will continue with the evaluation. So evaluation is a very easy process. You just take the value or values you have been given, plug them in for the appropriate variables and simplify to find the result. So for example, here we have px is equal to 2x to the power of 3 minus x to the power of 2 minus 4x plus 2, and p minus 3 is asked. So what we are going to do, we are going to just put minus 3 instead of x here. So let's write them down. Here we have 2x to the power of 3, which means minus 3 to the power of 3 minus x to the power of 2, which means minus 3 to the power of 2 minus 4x. We write here minus 3 plus 2. And then we have, this is minus 27. Minus 27 times 2 is equal to minus 54. We have here 9, but we have here minus, so it makes minus 9. Here we have plus 12. And we have here plus 2. What we get from here, we have plus 14. This makes plus 14, this makes minus 40, and this is equal to minus 49. You just put this value instead of x here. That's all you have to do. Let's look at our second example. Here we have px minus 2 is equal to x to the power of 2 plus 5x minus 2, and p1 and p0, they are asked. So what we are going to do here, to make this, to find p1, okay, first we look at this original polynomial. Here we have x minus 2, right? So we will try to make this is equal to 1. So instead of x, what should I put? Here I should put 3, right? Because 3 minus 2 makes 1. So which means here instead of x I will put 3. So here we have 3 to the power of 2 plus 5 times 3 minus 2, and here we get 9 plus 15 minus 2, and we get 22 from here. And the second one is the same. To find the p0, okay, we look at here what makes this 0. When we put 2 instead of x, we get p0, right? So we write here p0 is equal to, we put here 2 to the power of 2 plus 5 times 2 minus 2. This is equal to 4 plus 10 and minus 2, which is equal to 14 minus 2, 12. Now we will continue with the constant term. The constant term of a polynomial is the term of degree 0. It is the term in which the variable does not appear. So here, for example, we have px is equal to 3x to the power of 2 minus 2x plus 4. So it's asking what is the constant term of this polynomial. We already actually know that here 4 is our constant term, but sometimes you will see much complicated questions, so you will need to use this trick. What we do, instead of x here, we write 0, okay? Instead of x, we write 0, which means we will find p0. Let's look at this here. We have 3 times 0 to the power of 2 minus 2 times 0 plus 4. So from here, these are 0, so we get 4. Okay, you just need to destroy these terms with the variables. Okay, let's look at the sum of coefficients in a polynomial. So here, what you should know, that you should find p1. Okay, so instead of x, you write 1, and you will find the sum of coefficients. Let's look at this example. 2x to the power of 2 minus x plus 2. So how we find it? we just write 1 instead of x, okay? So we write here p1 is equal to 2 times 1 squared minus 1 plus 3. We have here 2, we have minus 1, 1 plus 3, we get 4. Also, without using this trick, we can also find the sum of coefficients. Let's look at, we have 2 here, we have minus 1, 2 minus 1, we get 1, plus 3, we get 4. Same thing. But as I said before, like here, sometimes we can see much complicated questions. In those questions, we should use this trick. Let's continue with other examples. So here we have px minus 3 is equal to 5x to the power of 3 minus x plus 11. What is the sum of coefficients of this polynomial? Don't forget, instead of x we put 1. We don't have to put this part is equal to 1, okay? We just put 1 instead of x. So here we get p minus 2 is equal to, here we have 5 times 1 minus 1 plus 11 is equal to 5 minus 1 is 4 plus 11, it is 15. So our answer is 15. It's also obvious here. Here 5 we have, minus 1 we have here, it's 4 plus 11, it is equal to 15, the same answer. Let's look at this example. Px is equal to 3x to the power of 3 plus 2x minus 1 this all to the power of 2. Okay, if we extend this polynomial by taking a square of it, it will be too long, right? So what we do, we use our tricks. So to find the constant term, what we should do, we should put 0 instead of x, right? So we should find p0 here. Sum of coefficients is the same. What we should do, we should put 1 instead of x, right? So we should find p1. Okay, let's find this. So the first one, p0 is equal to 3 times 0 plus 2 times 0 minus 1 to the power of 2. These are 0 minus 1, and we get here 1. And here we should find p1, right? So we have here 3 times 1 plus 2 times 1, because this is 1 to the power of 3, it's 1, and minus 1 to the power of 2. This is 3, 5 minus 1, it's 4. So the answer is 4 squared, which is equal to 60. Let's continue with the sum of the coefficients of even powers and odd powers. So we have specific formulas for these. For example, when we have a polynomial and it has powers like x to the power of 2, x to the power of 4, x to the power of 6, we use this formula. Instead of x, we write 1, and we find p1 plus p minus 1 over by 2. Okay, this is a specific formula for this. And for the sum of the coefficients of odd powers, we have this formula, p1 minus p minus 1 over 2. For example, this polynomial is given, and it's asking the sum of the coefficients of odd powers. How we find this? We find p1 minus p minus 1 over 2, like here. So what is p1 here? Instead of x, we put 1. Here we get 1 squared plus 4x plus 1 to the power of 2, 1, sorry, this is 1 plus 4, it's 5, plus 1, it's 6, 6 to the power of 2, it's equal to 36. And this is p1. P minus 1 is equal to, here we get minus 1 squared is 1, this is minus 4 plus 1 square, we get here 2 minus 2 to the power of minus 2 square, it's equal to 4. So we put here in the formula what we get. P1 is equal to 36, P minus 1 is equal to 4, so this is equal to 36 minus 4, it's 32 over 2, and from here we get 16. All you need to do is just you put the values in these formulas.